Hi, welcome back to my channel. It's the day 2 of the problem solving series. I hope you all are doing great. So today we are going to discuss about two different problems. One is the cadence algorithm and the other one is sorting of an array containing zeros, ones and twos together. So we'll be discussing about the various solution approaches and the time complexity and space complexity associated to each and every solution. Before starting off, you can feel free to drop your suggestions in the comment section. It will help me to improve my content, and if you have any solution which is better than whatever is being presented in this video, feel free to drop that in the comments too. It will help all of us. So let's get started. All right, so this is the problem for today. Given an integer array nums, find the subarray with the largest sum and return its sum. Now, what is a subarray? Let's look into what is a subarray first. We are given an array like this: 1, 2, 3, 4, 5. Now, sub-arrays that are possible out of this array is 1, 1, 2, 1, 2, 3, 2, 4, 3, 4, 5. So these are the possible sub-arrays. And what are the subsequences that are not a sub-array? So 2, 4, and 5 is not a sub-array. So a subarray needs to be contiguous. Any subsequence that can be found out of an array and that is contiguous in nature, that is a subarray. So what not is a subarray is any subsequence which is not contiguous in nature. So 2, 4, and 5 is not contiguous in nature. That's why it's not a subarray. Now let's move into the question. So for this example, we have this array given, and this one is the subarray 4, -1, 2, and 1, which is having the largest possible sum, that is 6. So 4, -1, 2, and 1. See, this is contiguous in nature. Then for this one, we have one element, so that element is the maximum possible subarray sum. For this example, we have 5, 4, -1, 7, and 8. So here in this case, 5, 4, -1, 7, and 8, this is the maximum subarray sum that can be found out of this array is 23, and that is the array itself. We have constraints given as nums.length lying between 1 to 10 to the power of 5, and nums of I lies between -10 to the power of 4 to +10 to the power of 4. So let's jump into the iPad screen. So what are the possible solutions which you can think of while looking at this array example? Let's take a shorter array, considering 1, 2, 3, -4 is our array. So we can think of forming all possible subarrays first, right? So 1 is a subarray, 1, 2 is a subarray, 1, 2, 3 is a subarray, 1, 2, 3, -4 is a subarray. Then we have 2 a subarray. We have 2, 3 as a subarray. We have 2, 3, and -4 as a subarray, right? For using 3, we have 3 as a subarray, 3, 4, 3, 4, -4 as a subarray, and using -4, we have -4 as a subarray. So these are all possible subarrays that can be formed out of this array. So the technique I am following to create all the subarrays is I'm considering this element, then I'm considering this element, then I'm considering this element, and then I'm considering this element. So considering the first element, we form 4 such subarrays of an array of length 4. Considering the second, we can form 3 such subarrays. Considering the third element, we can form 2 such subarrays, and considering the last element, we can form 1 such subarray. Now, if our array contains n elements in total, if the array contains n elements, so considering the first element, we can form n subarrays. Considering the second, we can form n-1 and so on till 1, right? So the total number of subarrays is this one. You find a pattern, right? We have this 1 plus 2 plus 3, then n-2, n-1, and n. So this is the total number of subarrays possible. Now, what is the result or value or answer in terms of n? It is n into n plus 1 by 2, right? Sum of first n natural numbers. This is n into n plus 1 by 2. Now, to form these n into n plus 1 by 2 sub-arrays, we can write a loop like this. For I equals to 0, I less than n, which is the length of the array, I plus plus. And the inner loop will be somewhat like this. For j equals to I, it starts from I. Initially it's 0. Then in this case, it will like iterate through this entire array 0, 0, 1, 0, 2, 0, 3, like this. If it is 2, say for instance, if the index changes to 1, that is, it's pointing to this one, then 1, 1, 2, and 1, 3. These are the possible iterations which can happen inside of the inner loop, j less than n, j plus plus. So inside of this, we can like calculate the sum of the subarray and also maintain the maximum value, right? So the total number of operations that happens in these two loops are nothing but equal to the number of subarrays that can be found out of this array, right? So for I equals to 0, the inner loop iterates for n times, right? For I equals to 1, the inner loop iterates for n minus 1 times. For I equals to 2, the inner loop iterates for n minus 2 times, right? So the number of times these two loops run together is order of n into. So these are the number of operations that happens inside of these two nested for loops, right? So we can simplify it. Order of n square by 2 plus order of n by 2, which is equivalent to order of n square. Therefore, using this solution, we can arrive into the result, but the time complexity will be order of n square. Since we are not using any extra space, the space complexity is order of 1, constant space. Now, can we think of a better solution? Yes, we have a better solution also. Now, if our array is like this, 1, 2, 3, and minus 4, we start summing up. So initially, we maintain a sum variable. We maintain a max variable. Sum is initialized to 0. Max is initialized to int min, or the minimum integer value, right? So we iterate through the array. Initially, I equals to 0, or the loop variable is 0. Index is 0. Sum gets changed to 1. Then on the next iteration, sum gets changed to 3. 1 plus 2 is 3. Maximum in this iteration is changed to 1, as 1 is greater than int min. Then here we get a 3 as a sum. So the maximum so this maximum variable is updated to 3. Then we take a 3 from the array, like index is now I equals to 2. 3 plus 3 is 6. 6 is greater than 3. So I update max. It is updated to 6. Now I have I equals to 3. So at I equals to 3, the element value is minus 4. Minus 4 is added with 6. It gives a 2. But 2 is not greater than max, right? So max remains as it is. Now let's like modify this array. Say for instance, we have an array like this. 1, minus 2, and then we have a 3, right? We have an array like this. Now we are at I equals to 2. Now iterator increases I value to I equals to 3. Now at I equals to 3, we have 1. So 2 plus 1 is 3. Sum gets updated to 3. It's still less than max. So max remains as 6. Then we have minus 2, or we can change it to minus 3. And this, let's change this to minus 3 and minus 1. So we have 2 at, so we have minus 4 at I equals to 3, right? So it is resulting in a value of 2 here, and max remains as 6, right? Then we encounter a minus 1. minus 1 changes 2 to 1. Still max remains as 6. Then we encounter a minus 3. Minus 3 changes 1 to minus 2. But still max remains as 6. But minus 2 will eventually contribute to decreasing the sub-array sum in further iterations, right? It will always contribute to a negative effect on the entire sub-array sum. So we change this sum, or we reset this sum to 0 on encountering a minus 2, right? I change the sum to 0. Now I encounter a 3 this time. So sum becomes 3. But 3 is again less than less than 6. So it remains as 6. Say for instance, we have something like this after this. Say for instance, we have a 9 after this, right? So in the next iteration, 3 plus 9 will be 12. And the sum and the maximum value is now 6. It is compared with the sum value. It is less than the sum value. So I update the maximum value. So in this case, our maximum possible subarray sum is 12. And it is found with these two elements. So this algorithm is known as cadence algorithm or cadence algorithm, whatever you may pronounce it. So this algorithm will help us to find the maximum possible subarray sum with a time complexity of order of n and a space complexity or with order of 1 or constant space. So, all right, so let's look into the code. I define an integer max variable as integer dot min value. It is defined as the integer min value. I define a sum variable as sum equals to 0. Then I start iterating through the loop. I start navigating through the elements present inside of the array. I less than nums dot length, I plus plus. I start summing the elements up. Sum equals to sum plus nums of I. And max will be initialized to the maximum value, math.max, max comma sum. So whichever is maximum, max or sum is initialized as the max. Now, if if the sum at any instance becomes less than 0, then it will have a negative impact on the rest of the sub-array sums that is getting generated. So instantly we reset the sum value to 0, right? So this is it. Now we'll return the maximum, return max. Let's run and see. Runs correct. Let's submit the code. All right. So this is our solution for the maximum possible subarray sum. So it beats 99.52% since we have reduced its time complexity to order of n. And space complexity is already order of 1. Okay. So this is all about the maximum subarray sum problem. If you have any doubt, any question, feel free to drop it in the comment section. Thank you.